For the first part, you have a table up the top here that shows you your metal atoms or your metal ions with the pluses and your non-metals up here. So the formula that's required here is for this guy. If you're not sure what they are, use your periodic table or look them up on Google. Very good Google. Google's a great chemist. This one here is potassium chloride. So you just write it in. Chloride. It's chlorine as a compound in the periodic table, but when it's joined to something like salt, it becomes chloride. And some of them have changed meanings, names. Now on the other side of the sheet, so just carry on through these ones. On the other side here, you need the formula. So the way that you do is you look up silver bromide. If you're not sure what silver is, you can Google that too. It's actually Ag. So I'm going to write down here Ag plus. And then you want the bromide, and if you research that, you will find that it's Br minus here. So Br minus. Now, because the charges here are the same, this formula is just 1:1 ratio or parts. Okay, AgBr. Now let's do one that's slightly different. This one here is a bit tricky. It's harder. So I'll just do this as an example. Magnesium phosphate. Magnesium is from this part of our table. It's a 2+ charge. Once it shares away its 2 electrons, it's got 2 more protons, right? So once the 2 electrons go, you have a charge of +2. So who does it want to lend them out to? Well, in this example here, phosphate. So anything you notice that has 8 is, in this case, it's phosphorus, and 8 means oxygen. So it's a P and a O compound, and we notice that this is this guy here. So this is our phosphate ion here, or compound. So it's PO4. Now it has a combined charge for the entire phosphate as a 3-. So we're just going to write this down. So it's a PO4, 3-. Now that 3- applies to the entire phosphate. So the phosphate is 1 phosphorus and 3 oxygens together. And we just write that as a little group. And it's going to join up with the magnesium. So we don't have to worry so much about the composition of the phosphate, but that's just what it is. Now all we worry about the fact that it's got a 3- charge. And we have to put the right ratio of this with the right ratio of magnesiums. So one way to do this, is various ways, is to look for the, the multiples of 2, 2, 4, 6, 8. Yes, it's mathematical like fractions. And the multiples of 3 are 3, 6, 9, 12. In this case, I'm doing this because 2 and 3, there's no 1s in there, so we can't just sort of double or triple one of them. We kind of have to find a common multiple or a common base. The lowest one occurring is 6 in both cases, which means this has got a 2 charge. So 3 of these will give us a 6 charge. So I'm going to go with a little bit of clear space. Just going to rub this guy out. So I'm going to go with 3 of those. So Mg2+. Now if I have 3 of them, I'm just going to go Mg2+, Mg2+. And to get a 6- on the phosphate, I will need 2 of them. So I'm going to have a phosphate and a phosphate. So together they have a 6 charge that comes together. How do I write this? Mg with a 3 down below for magnesium. And phosphate, PO4, because I need 2 of those, I'm going to wrap a bracket around the group and double up the group with a 2 there. So the answer for that one is Mg3, PO4. If you're unsure, twice, PO4 twice. Now, if you're unsure of anything, just Google it. Next part of the worksheet is determining the type of equation, the type of reaction, and balancing it. So there's 2 parts to this. Let's look at the first one here. This one is potassium plus some number. So some number of potassium atoms or ions plus some number of chlorine gas. So notice that that's a pairing of 2. Comes together to form a KCl. Now that one there is actually balanced, so you'll rely on these individually balanced, because remember potassium and chloride was a 1 + 1 -. So that is the correct thing there. Now because we've joined them and it's made a new compound out of the reactant, so the product is a joined up one, then this type of reaction we can say is synthesis, this guy here. So we're going to write synthesis type for this. Now the other thing we have to do now is balance it. So we don't have to balance anything but the start numbers. So the way that we balance shown in class is we write down each component. So we have potassium and chloride. On the left side and on the right side, the potassium started off here as just 1 and it became 1 on the other side. The chlorine, we have 2 on the left side, and on the right side we end up with 1. So that's problematic for us because it's not balanced. We need the same number on both sides. So we might have to adjust the ratio of the compounds to make sure that it's balanced. All chemical equations must be balanced at all chemical reactions. So looking over here, we need to increase the chlorines. So what we do on the right side, on the product side, to increase the chlorine, we don't just go putting a little 2 downstairs here. We have to increase that entire product. We can't mess with the products. We're just going to double it up at the front. So we're going to put a big 2 there. And now we're just going to check our mathematics, and we're going to say, okay, now I've got 2 there. And on the left side I have 2, so the chlorine's good. But let's have a look at the potassium. On the right side over here, because I've got 2 potassium chloride molecules, I also have 2 potassiums. So on this side here, the right side is 2. Oh, and look, the left side isn't 2 yet, so I need to put a coefficient or a number in front of the number of the potassiums as my final step and put 2 there, which gives me the 2 there. So everything is balanced going in and out with every single component, the potassium and the chloride. So that is now a balanced equation. See how you go with the rest of them. Send me emails or questions if any of them pop up too hard. For the next part of section D, it says from the following pairs of reactions, which is a synthesis and which is not. So let's look at the first pairing, which is these 2 pairs here. We have, let's make this bigger. So we have, in the first instance here, sodium chloride and silver nitrate, and it's making silver chloride and sodium nitrate. So are we starting with separate components and making one? No, so it's not that one. Down here, calcium oxide and carbon dioxide comes together to make calcium carbonate. Now, it looks like the first molecule, but we've got some extra, we've got a carbon in there and an oxygen in there, so it's actually taken it from this part here. So we have actually combined these 2. So it is this one, okay, and not this one, okay? So the synthesis reaction is this guy here. That's all you need to do for this part of the worksheet. Just go through the rest of them and pick out which ones of the pairing are synthesis and not. So this one's quite a few to do here. Next one here, stop if you don't want the example here, but you're choosing from the 2 which one is a decomposition. So I'm just going to randomly choose this one to show you as an example, and I'm going to take a look at them and say, okay, we have decomposition. Okay, so Na2O, which is sodium oxide, plus carbon dioxide. Now that seems to be joining together to make a bigger molecule, so it's sodium carbonate. Next one down, H2SO3 plus H2O plus SO2. Okay, so this one here started off as one molecule and all the elements broke down into 2. So we can say this one decomposed. So I'm just going to tick that one off as the decomposition. Stop here if you're all good. Otherwise, let's have a little quick example from part 3, which says we're looking for a combustion and which one is not. Now, combustion is, if you look at your class notes, you have to add lots. You normally start with a CH type compound, which is a fuel, a hydrocarbon, and it'll have some numbers beside it like C2H6, something like that. And we add lots of oxygen, and we normally form water and carbon dioxide. So the water comes off as steam and the carbon dioxide comes off as smoke when we burn the fuel, all right, like a gas, a natural gas, okay? Methane is the one I'm doing here. So let's have a little look and see if we can identify the combustion reactions from the pairings. Yes, that looks like a fuel. It's a hydrocarbon. We're adding 6 oxygens. We're making carbon dioxide and hydrogen. That looks like could be the go there. So I'm just going to put a little asterisk. And looking down the one below, we have Fe2S3, iron sulfide, and we're adding oxygen to that. And we've got FeO3, so we've actually put some oxygen onto there and sulfur dioxide gas. So this one here looks like oxidation because we've made a new compound, an oxide compound. This is much like the magnesium that we burnt in class. We made magnesium oxide. So I'm just going to write that one down for your memory. So if you remember, we had magnesium as a metal that was a solid, and we added oxygen via burning it, but we actually made MgO. In this case here, this is what this one's doing. We're making the oxide. That's just background anyway. That's the one that you want. That is the combustion reaction because it has carbon dioxide and water, and those are the key elements. Just to help you out here with the next questions, why don't you Google these and see how you go. If it's these that I've been asked for help with, really happy to show you again or provide the answers. Just let me know. Thank you.